All right, students. So instead of having this down in our books, we could actually look at this video continuously over a period of time and get a nice understanding as to what the continental drift theory is. Remember, this continental drift theory was just a statement, an ideology, and whatnot based upon observations, all right, of what the continents, how they shape today, and potentially how it was several millions of years ago. All right. Now, students, this continental drift theory was in fact created by a guy called Alfred Wegener. All right. He first theorized that this whole big supercontinent here was Pangaea. The Earth had a major or a singular supercontinent. I call it Pangaea. Okay, spelling. And this was an estimated 225 million years ago. Estimated. I take these values with a pinch of salt. Okay. And that was within the Permian period. However, internal forces within the Earth resulted in the actual land masses of this particular continent, supercontinent, to be pushed apart further into Laurasia and Gondwana. And this was primarily 200 million years ago, which is technically 25 million years after the Permian period. You call it the Triassic period. All right, forget the periods, let's focus more on the Laurasia Gondwana Pangaea, the actual continental shift. Now, internal forces where the molten materials are in fact moving within the mantle will cause the actual crust to eventually break apart. Remember the Oreo and the milk scenario we talked about in class a couple minutes ago, right? So keep that in mind. All right. So we have Laurasia and Gondwana, which is two major subfractions of what Pangaea used to be. And as the progression of time, when I'm talking about the progression of time over a geological time scale, which is in fact millions of years, in this case, 50 million years after, which is an estimated 150 million years ago, which is within the Jurassic period, we realize that the continent shifted apart even further. Now, students, you're realizing here that the actual blue represents the land masses and the actual white represents the bodies of water. And you realize more and more bodies of water are in fact being established as the continents, or I should say as the land masses, push further away from each other. From this diagram, you can actually see, wait, this one here looks like very much like South America, and this one looks very much like Africa, and it makes sense. Now, with the progression of time even further, moving away from the Jurassic period, all right, extending just about 25 million years ago, which is just after, or perhaps during, or just a little before the dinosaurs were fully extinct, all right, and let's assume that's an average statistic, these continents simply were pushed apart even further. All right, these land masses were pushed apart even further because of internal forces within the mantle, forcing the crust to simply drift away. All right. Now, the reason why it will drift away so slowly is because these things happen very slowly, as a matter of fact. When you say geological time scales, you are in fact talking about periods of time whereby the land masses themselves will be moving at several millimeters or several centimeters, or perhaps in very rapid scale, several inches per year, which is essentially over a very long period of time it will take to actually show any profound change. Now, moving here into present day, we know fully well there are 7 major continents of the world. All right, as we listed them in class, and you can see it on the screen here, we have North America, South America, Antarctica, Africa, Europe, Asia, and Australia. All these 7 continents today constitute the entire planet as we know it today. All right. Now, students, it is because of this continental drift theory and the plate tectonics understanding I spoke about earlier today, we can understand that the bodies of water, right, are very, very unique because of this placement of the land masses. In the middle here, right, between South America and Africa, just north of Antarctica, and also between North America and Europe, this body of water here is called the Atlantic Ocean. This body of water just below Asia technically is constituting part of the Indian Ocean. All right, the Indian Ocean essentially. On this wider spectrum, remember the globe is in fact round, right? Well, geoidal in nature. This area here, which is technically east of Australia, and also this area here, which is technically west of the Americas, that constitutes the Pacific Ocean, the largest ocean in the world. All right. So it is because of the drifting and the shifting and the movement of these plates and crusts. All right. It resulted in the world as we see it today. And the world as we see it today is very much, it is not uniform. It is varied in so many different ways. All right. Now, students, I want to bear in mind this jigsaw puzzle fit between South America and Africa. You can actually see it. South America and Africa, look, there's a small groove on the side of Africa, the western side of Africa, and there's a small little bulge on the eastern part of South America. It has a kind of jigsaw puzzle fit. Look at this little curvature in North America together with this bulge in Africa. It fit there as well. Look at the region north of Africa, just south of Europe in the Mediterranean region. This would have actually fit properly as well. You understand what I'm saying? All right. And this will be applicable in the global spectrum. If you look at Google, we can actually see that. Now, the theory was actually fortified by evidence where on the eastern part of South America and on the western part of Africa, they found fossils which are in fact unique and cannot be found in any other parts of the world. All right. So that's a what you call a paleontological pieces of evidence, fossil evidence, which shows basically that the continents of South America and Africa were technically closer, if not joined together. All right, and that's an important thing. You understand? So apart from the physical jigsaw puzzle fit that we can actually see here, we must understand that there are other pieces of evidence which fortify this whole big concept of continental drift. All right. Now, if you look at Google Earth here, we can see that the world as we see it is very much kind of similar to what we have. Look at this little area here, with this Arabia would have actually had a similar fit along the side of Africa and whatnot. So you can see those fit. All right. You could also see here the jigsaw puzzle fit between South America and Africa, and that bulge which exists in Africa here, which is also applicable to the actual indents in North America. So all these continents they were very much close to each other, as a matter of fact. Now moving down, another piece of evidence was found basically in Antarctica. It was mentioned that they found coal deposits in Antarctica. Now Antarctica is in fact the coldest part of the Earth. Temperatures actually reach an estimated 44 or even 45 degrees Celsius. Minus 44, minus 45 degrees Celsius rather. All right. Very, very below 0 degrees, that is. All right. And they even found coal deposits, and that coal deposits, for coal deposits to actually be formed, they must need relatively warm temperatures per se. All right, so keep that in mind. So apart from physical understanding of the shape of the Earth, they also found fossilized evidence and also evidence in different geological areas of the Earth. That is geologic evidence as well. All right, students. So I hope this was able to juggle your mind and basically allow you to understand even better. All right, keep safe. Have a good one.